So let's take a look at the information that we have for cosecant. So there's that domain. Domain is all reals except, and again, this is for the parent function, all the multiples of pi, 0, pi, 2 pi, 3 pi, and so on. The range, the graph only exists from negative infinity to negative 1. It stops, and then from positive 1 to infinity. So in between negative 1 and 1, the graph does not exist for cosecant. I have no x-intercepts and no y-intercepts. Again, this is for my parent function. I have those asymptotes, so I have infinite discontinuities that are happening again at those multiples of pi where my asymptotes are occurring. This is another odd function. It's symmetrical about the origin. Unlike the last two graphs, tangent and cotangent, I am back to having minimums and maximums. Now, these are not absolute. These are going to be relative because my graph goes down to negative infinity and up to positive infinity. So these graphs are going to have relative minimum and relative maximums. And they're going to be, again, infinitely many. End behavior does not exist. Oscillating again between negative pi and pi. Now we are back to a period of 2 pi. Okay, it's going to take 2 pi radians for the graph to repeat itself. If we go back and look at that graph of that parent function, you can see that it's going to take a period of 2 pi in order for you to have both of those branches. And it doesn't matter where I start my period. If I start my period here, now I have 2 branches. Typically, the initial portion of my cosecant graph usually goes from 0 to 2 pi, or you can do from negative pi to positive pi. It doesn't matter. As long as you have a full 2 pi radians for your parent function, you can see what it looks like. And then again, there's that general form. We have our greater than 1 vertical stretch, between 0 and 1 vertical shrink. If it's negative, it reflects about the x-axis. Period, we're back to 2 pi divided by b. If b is greater than 1, we have a horizontal shrink. If b is between 0 and 1, we have a horizontal stretch. So like tangent and cotangent, the first thing that you're going to do is you're going to go through and you are going to plot those vertical asymptotes. So you're going to take your bx plus c and you're going to set it equal to negative pi and positive pi. And those are going to give you your 2 branches, your 2 U-shaped pieces in order to complete your full period. Now remember that you are going to have a third asymptote halfway in between these. This is the beginning of your period and this is the end of your period. And you're still going to have a vertical asymptote in between them, okay? Halfway in between them, always halfway in between. And then we have our vertical shift, up or down. Now, going back to cosecant, you can sketch the graph of a cosecant function by plotting the vertical asymptotes and finding corresponding relative minimum and maximum points. Okay, so what we're going to do is we're going to start with those asymptotes, and then we're going to find our mins and maxes and then branch out from there. Those points that I showed you in the last graph, we'll go through and find those without graphing the sine function. And then if there's a vertical stretch or shrink, that of course makes the graphs steeper or not as steep.